Determining the baffling factor via CFD modeling, a short video featuring Dr. Kevin Linfield. Water treatment tanks are used to incorporate sanitizing chemicals into water for both residential and industrial applications. These tanks often use a series of internal structures or baffles to redirect the flow for increased residence time. The baffling factor is a way of characterizing the effectiveness of flow through a given tank by quantifying the mixing of the chemicals. By finding the time for the tracer concentration to reach 10% of the total flow of the tank exit and comparing it to the theoretical time for the entire fluid volume to fill the tank, the baffling factor can be calculated as a simple ratio. This baffling factor can range from 0 to 1, with higher values corresponding to better mixing. The water tank analyzed for this example consists of a cylindrical tank 33 feet in diameter with an 8-foot water depth. The interior consists of 3 baffles, each 24 feet long and spaced 7 feet apart. One method to find the baffling factor by computational fluid dynamics involves modeling a dye injected into the inlet and observing the concentration throughout the tank over time. The fluid movement inside the tank was modeled to determine the time taken for the dye to travel from the inlet to the outlet. The simulation process began with a steady state run to establish the basic flow profile and was then followed by a transient or time-dependent model with the injection of dye. From the results of the transient simulation, the numerator of the baffling factor formula can be found by monitoring the mass flow fraction of dye at the outlet and extracting the time at which dye makes up 10% of the total flow at the outlet. The denominator is determined by dividing the volume of the tank by the design flow, giving the ideal tank fill time. The resulting ratio of these two times yielded a baffling factor of 0.6 for this water tank. Unfortunately, the baffling factor goal was 0.7, demonstrating that the current design would not satisfy the industry standards for its intended application. Additional tank designs may require adjusting the number, size, or spacing of the baffles inside the tank to increase the baffling factor. For more information on flow modeling and testing, please contact Airflow Sciences. Thank you, and have a wonderful day.